Assalamu alaikum and welcome to this short video in which I'm going to be discussing the requirement or the need for containerization, especially in the context of DevOps. I've taken this image from Google. It explains to us very clearly the DevOps process. The DevOps process basically is built up of uh, several components. The first one, you can say it starts with coding. You build up uh, a software or a module of a software. Then you obviously build the whole application. Then you test it. Then you release it. Then it is deployed for an operational use. Uh, and it is then continuously monitored. And then this whole cycle continues. So in the monitoring phase, we come up with certain bugs and problems. So then we are making a plan to go back to the coding phase again. Initially, this process used to take a lot of time, but due to the creation of the DevOps process, this has become very fast, very efficient, and very effective. Primarily for the coding phase, we must use Git as a code repository and also as a communication platform between the developers. And for the project management, we can use Jira and Confluence. Both of these tools are by the Atlassian company. To build your code, we can have certain build tools like Maven or Ant or SBT. Particularly with respect to Java-based applications. And for testing, for example, we have the famous JUnit framework for unit testing of the builded application, along with SE as well. And when we release when we give the first release of the application, so then for that, Jenkins is a very famous tool which can be, which acts as a interface between the testing scenario and the deployment scenario. So it helps to couple up these two parts together. And for the deployment, we primarily have Docker because we need to containerize the whole application after it has been tested. And we are going to be discussing precisely that right now. Obviously, we can also use the cloud here if we are not using an in-house setup. During the operational testing of the application, we have 2 or 3 very famous tools. Particularly, we use Ansible. In most cases, Ansible is being used to manage the application at the operational level. You can also use Chef, but Ansible is more famous. And if we are using obviously we are using the containerized scenario. So in order for the multiple containers to talk to each other, to make a scalable containerized application, which is very lightweight, very easy to manage. Obviously, one of the tools we can use is Kubernetes, but we can also use Docker's own tools to manage multiple containers. Then after that, we need to obviously Splunk is a very famous application which is used to monitor the deployed application for any errors, any runtime errors, logical errors, hardware errors, software errors, etc., etc. Nagios can also be used for that. And any problems that come up in this whole deployment and operational process are then sent back to the coding team, and then they are able to actually execute the whole process very quickly again. So that's the essence of the DevOps process. Now, I like to specify here that when developers are working at the coding level, so you need to spend a lot of effort in configuring the environment, because all of us know that coding requires us to use different APIs and probably different development environments coupled up together. Obviously, we can collaborate through Git and Jira, But I mean, if you have to develop an application, you need to use different types of modules. You need to set up a development environment. You need to configure that environment over which the application is going to run. So, for example, if I'm making an e-commerce application, so I might need to use some module related to text processing as well, and I might need to use some specific databases like MongoDB or Redis, for example, and all of them have their own configuration requirements. So, in other words, when the code is ready to be built, then that means a lot of things have already been done in that environment. So when the code is built, then it is up to the testing people to actually test the code. In this case, the problem is that the environment which has been built up at the coding level is not available to the testing guys. So what happens is the testing guys either build up their own environment or use the environment which has been created by the developers at the coding level. So that creates some sort of a disharmony between the whole process, because it's sort of a bottleneck to have this limitation. So because the coding the coding guys will need to spend some time with the testing guys uh, to develop the environment, to configure the environment, or they may need to provide access to their own PCs so that the testers can test the code at the development platform. However, as the testing guys also have to write their own code and test many things line by line, so it's better for them to have their own environment. But like I said, this creates a bottleneck between these two departments, and we need to cover up that in some way. And that is done through containerization, particularly through the use of Dockers. So, whatever environment the coding people have created, that environment can be Dockerized and handed over to the testing guys as a Docker image. The testing guys can just execute the Docker image and they have the whole environment up and running. So they don't need to install any new software. They don't need to look at the version numbers of anything. They don't even need to seek what is the configuration of their own PCs. They just need to have Docker up and running. They will just get the Docker image from the developers, and then that image can be run on the testing PCs, and the whole application will just be charged up in that way. Now, inside the Docker, inside that container, or you can say inside multiple containers, the testing guys can make their own changes and develop their own Dockers. So we can have a development Docker for the particular application. We can have a testing Docker, and so on. And that's why when you're releasing it, at the deployment phase, we have to use Docker, because if we don't use Docker, then there's no way we can execute this whole process without the use of Docker, because we are saying that we are able to modify the code to cater for operational errors in, let's say, almost near real time, just in a few minutes or a few hours. Even that is possible, but that is only possible if you're able to port this huge application through Dockers to the operational level. If we don't have the Dockerized version of the application, then there's no way we can port that so quickly at the operational level, because then we have to deploy the application, that development environment at the testing level. We have to deploy it again at the operational level. So that's going to take a lot of time, and there's going to be a lot of disharmony between these deployments. But when we Dockerize it at the coding level, let's say after building it, we Dockerize it, then that Dockerized image can be used across this whole testing, release, deploy, operation, monitor. and it can only be changed, let's say, at the coding level later on. So even if the testing guys are able to detect some errors, uh, so they can directly talk with the coding guys there and then, and those errors can be rectified, and the new Docker can be given to them, or they can wait until they have crossed through this whole process of operational analysis, monitoring, planning, and then everything comes back to the developers again. So it's a pretty fast cycle, primarily because we are able to ship the whole application inside a Docker container or multiple Docker containers, either using Docker Compose or Kubernetes. The whole application can be containerized, and the testing guys and the operational guys can build up their own Docker images based on the Docker image given by the development team. And that's how this process becomes fast and efficient.